Alright, today we're going to start getting into the quadratic formula, which you have learned before. For some reason, the book, even though this was going over the quadratic formula heavily, nowhere in this lesson does it actually have it written out, so I want you to write it right there. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now I wrote that b squared minus 4ac in red because we're going to talk about that specific part of it here in a little bit. That part of the equation is going to give us information about the solutions. This may look kind of complicated. I really don't think it's that complicated, because what you're going to do, which first you have to make sure your equation is in standard form. So on this one, my a would be 1, my b would be negative 4, my c would be 3. I just plug it into the formula and it spits out the answer. Okay. Now let's go. I want to look at this one down here. So I like the way that they go through it as far as the actual steps they take. It's very similar to how you're going to see me do it whenever I'm working these up here. So the very first thing they do, obviously, is they identify the a, b, and c. After that, they plug everything in, and notice how they're putting parentheses around everything. That is especially important if you're putting in a negative number. After that, they go through, they get rid of all the parentheses. Okay, the negative 40 becomes positive 40. Negative 40 squared becomes 1600. Negative 4 times negative 99. That becomes negative 1584. And then the 2 times negative 4 becomes the negative 8. After they've done that, the next step, it's a pretty small one, they just do that little addition or subtraction problem, whatever it may be. So that comes down to be 16. And then they take the square root of 16 to 4. Now, if 16 is a perfect square, if it is not a perfect square, this is when you would have to simplify that radical. Alright, that's whenever that stuff comes into play. Now, whenever you're doing the quadratic formula, what exactly are you solving for? Or whenever you factor, what part of the parabola are you solving for? Think about all the different characteristics of the parabola we've talked about. There's only about 4 of them. Okay, the roots. So a lot of times on that parabola, you're going to have 2 roots, so we've got to get 2 answers. The part of the quadratic formula that gives you the 2 answers is this plus or minus. Okay, so once you get to that part, you break it up, 1 with the plus, 1 with the minus. And then from there, you solve it down. And this one comes out to negative 5.5 and negative 4.5. Alright, so let's just kind of walking through that. We're going to do a few examples of this on the next page. We're going to go through 2. I'm going to go through 2 of them with you, and then I'll have you do one on your own. So, looking at B. Logan, what is my A, B, and C value? Okay, what's the coefficient of x squared? 1. What's my B value? Just negative 5. And C is negative 24. So I'm going to go through. I've got negative 5 plus or minus the square root of negative 5 squared minus 4ac all over 2a. come quiz or test time, which quiz time will be next class, doing that right there is probably going to get you a point. Just plugging it in all in the correct spot. Okay? But if you don't show that, then I won't know how you got there. So, next I'm going to get rid of all the parentheses. I've got the -5, which turns into +5. I've got -5 squared, which is what? 25. I've got -4 times 1, which doesn't really do anything. So -4 times -24 gives me, I believe, 96. Someone check that. Okay. Alright, so that is all over 2 times 1, which is 2. So the next step, all I'm going to do on the next one is I'm just going to add 25 plus 96. So I got 5 plus or minus the square root of 121 over 2. What is the square root of 121? 11. So I get 5 plus or minus 11 over 2. And this is whenever you break it off into 2 parts. 5 plus 11 is what? Divided by 2 is what? 5 minus 11 is what? -6. And -6 divided by 2 is -3. Okay? So on A, Mackenzie, what is my A, B, and C values?
Your A is -2, your B is -3, and your C is 7.
Okay. So I'm going to go negative B plus or minus the square root of B squared minus 4AC all over 2A. Once I have that, I'm going to go through and get rid of all the parentheses. So that gives me 3 plus or minus the square root. What is -3 squared? 9. What is -4 times -2 times 7? 56. All over -4. Next step, I'm going to take 9 plus 56, and I'm going to add those to give me what? 65. So I've got 3 plus or minus the square root of 65 over -4. Now 65 is not a perfect square like 121 was on the previous one. So again, this is whenever you would have to simplify that radical. Now to save time, you can't simplify the square root of 65. There's not a perfect square that divides evenly into it. Okay, so this right here would be my answer. That is my 2 answers right there. Alright, now if you can write that as your 2 answers. For whatever reason, if you just feel the need to write it twice, once with the plus and once with the minus, you're more than welcome to. It's still correct. But this tells me the exact same thing. You don't have to necessarily write it twice. Okay. I want you to go through D. Now before you start it, what's the first thing I need to do? I need to what? Add 7. So your C value is not -7. It is going to be +7. So go through the whole process. This one should turn out nice and neat like B did. There's the two answers that you should be getting to. -7 and -1. So on this next page, you've got 6 different graphs. Okay, which we've already kind of identified that the quadratic formula, Mackenzie, is what solves for the x-intercepts. So we're going to look at these graphs and identify the x-intercepts on each one. So the first graph in group A, what are the two x-intercepts? -2 and +2. On the second one, not -5, -6 and what? And 0. What about the first one in group B? And, oh, sorry, never mind. That's it. On the second graph, 4. What about both graphs in group C? Okay, there isn't one. So what we're going to do on the next page is we're going to do we're not going to do the quadratic formula for each equation. We're just going to do it for one for each one equation per group. Okay? And then we're going to look how doing that quadratic formula is what gives us those solutions. So looking at first this first question. Okay? And it's asking how can you look at a graph and tell the number of solutions. So I want you to put if the graph crosses the x-axis, okay. So if it crosses the x-axis twice, and most of you, this is probably common sense, there are 2 real solutions. If it crosses the x-axis once, there is 1 real solution. And if it doesn't cross the x-axis, there are, we'll go ahead and start writing this, what is called 2 imaginary. Okay, so no solution is no longer an option. If a solution does not actually exist, then we have to use our imagination to come up with it, which is going to involve I. Alright, so let's go through, just going to go to the first equation in group A there. So on that equation, Sarah, what is my A value? What's my B value? No. Okay, so what is it? 0. Alright, I've had a lot of students in the past that whenever they're missing a term, they will rewrite it with 0 in there so that they can easily identify that they've got an A value, a B value, and a C value. Okay? So I'm going to go through here. I've got 0 plus or minus the square root of 0 squared minus 4ac all over 2a. Now, does the 0 at the beginning, is that going to do anything? No. Does the 0 squared, is that going to do anything? No. So inside here I've got -4 times 1 times -4, which is going to give me what? 16. So I've got 0 plus or minus the square root of 16 over 2. What is the square root of 16? 4. Then I break that up into 4 over 2, which is 2, and -4 over 2, which is -2. Now look at this number right here. I want us to kind of focus on this number. Alright, 16. What kind of number is that? Okay, it's even, it's a perfect square. What else? I'm looking for a certain characteristic of that number that I want you to notice and me not to tell you. Throw other stuff out there. That number. Tell me about it. It is real. What else? Okay, it's positive. Alright, so underneath the radical, underneath the square root, we got a positive number and we got two real solutions. Okay, I want you to put that in the back of your mind and kind of remember that. Going to this one. Let's go through the quadratic formula on this. I'm going to go through this a little bit quicker. So I've got negative 6, which is positive 6, plus or minus. Negative 6 squared is 36, minus 4ac, all over 2a. So that's going to end up giving me 6 plus or minus the square root of 36 minus 36 over 2. 36 minus 36 is going to be what? 0. So I got 6 plus or minus the square root of 0 over 2. The square root of 0 is what? 0. 6 plus 0 is what? 6. 6 minus 0 is what? 6. So is the plus or minus square root of 0 doing anything? No. Alright, so I end up with 6. Oh, and that the 2a, sorry, that should be negative 2. So 6 over negative 2, which gives me negative 3, which is the one x-intercept that we got from the graph. Now looking at this problem, what is the number underneath the radical? 0. So on this one, we got 0, and we ended up with one real answer. The one above, it was positive, and we had two real answers. So you can probably all use your smart brains and figure out that the number we're going to get underneath the radical on this one is going to be what? The number is going to be negative, and so we're not going to get a real solution. So let's go through this quickly. I've got negative 12, which is positive 12, plus or minus the square root. Negative 12 squared is 144, minus 4ac, all over 2a, which is just 4. I'm going to put 4 there. All right, 4 times 2 times 19. Is that 152? Okay. So I get 144 minus 152 over 4. 144 minus 152 is what? Negative 8. So there's my negative number underneath the radical. So I now need to simplify that. So I take the negative, Keenan, I pull it out, and it becomes what? Positive. No, it doesn't. Sorry. That's what I get for listening to you. I take the negative out of the radical, and it becomes what? I. So now I need to simplify the square root of 8. What is the largest perfect square? Because I'm not paying attention. 12. What is the largest perfect square I can divide 8 by? 4. That becomes 4 times 2. What is the square root of 4?
2.
So I've got 12 plus or minus 2i times the square root of 2 over 4. Alright, which we could simplify that and make it look a little bit neater, but I'm not worried about, or not simplify it, I could reduce it and make it look a little bit neater, but I'm not worried about doing that right now. Let's go down to the questions below. Go to 4b. It says, when you use the quadratic formula to solve the equations, at what point did you know the solution was going to be an imaginary, or include an imaginary number? So what was the part of it that we had a negative number underneath the radical? That negative tells us it's going to be an imaginary number. So that b squared minus 4ac, part of the quadratic formula, that number is called the discriminant. And its sole purpose is to tell you how many and what kind of solutions you're going to have. You're going to have 2 real, you're going to have 1 real, or you're going to have 2 imaginary. So outside of knowing how to use the quadratic formula, you need to know these rules about the discriminant. If the discriminant is greater than 0, then you are going to have 2 real solutions. If your discriminant is equal to 0, then you are going to have 1 real solution. And if the discriminant is less than 0, which is just another way of saying negative, then you're going to have 2 imaginary solutions. In fact, I believe, yes, skip the next page. Go to 273 at the very bottom. Right here. Now, every time we've done the quadratic formula, it has to be in what form? The equation has to be in what form? Standard form. What equations are these in? Vertex form. Definitely not standard form. Correct. So, if I'm asking you how many and what kind of solutions on these equations, what do you think we need to do? Well, you can look at the vertex. You can do what? You can convert. So you kind of have 2 options. You can either convert it to standard form, which takes a while, and then you can do the quadratic formula, which takes some time as well, or you can use the characteristics of the parabola to figure it out. All right, looking at A, what would my vertex be? 3, negative 4. Is it going to be concave up or concave down? So if my parabola is roughly going to be that, how many and what kind of solutions do I have? 2 imaginary. On B, what is my vertex? 3, negative 4 again. Is it concave up or down? Up. How many and what kind of solutions? 2 real. On C, what is my vertex? 3 what? 3, 0. Concave up or down? Down. How many and what kind of solution? 1 real. You can just use the characteristics that we've talked about previously to figure this out without having to convert and doing the whole quadratic formula. Now the question on, it's not below it, I guess it's on the, nope, it is right here. Okay, so this just kind of breaks this down a little bit more. And knowing these rules, and it's not that difficult, it's a lot easier than having to do the whole quadratic formula. So we're talking about a vertex as it's above the x-axis. If it is concave down, you have two x-intercepts, so you have two real roots. We're not going to fill out that last column because it's the same as the previous. It's just wanting us to write 0 instead of root, which makes no sense. So, the next part, you've got your vertex is below the x-axis, it's concave up, so you're going to have two x-intercepts, so you will have two real roots. Vertex is below the x-axis, it's concave down, it does not cross the x-axis, so you have two imaginary roots. And then if it's on the x-axis, it doesn't matter if it's concave up or concave down. This is the situation where you're going to have one real solution. Okay, so we've talked about the standard form. You do the quadratic formula. We've talked about vertex form. You find the vertex and you look at whether it's concave up or concave down. This question down here, what form is that in? Factored form. How many and what kind of solutions are in that one? Two what? Two real. How do I know that? Because what? Because in factored form, it gives you the x-intercepts. If you had factored form and it did not have two real solutions, it would look something like this. So that would be two imaginary, is what that's an example of. Okay? So what they gave us is two real. That right there, something that would look kind of like that is two imaginary. So I want you, again, skip the next 2 pages and go to this right here. So what this does is this breaks it down pretty heavily about what kind of solutions you're going to have. Okay, so this is really all talking about the discriminant. Alright, you're talking about, if you're looking at the graph, you know you have two x-intercepts, you have one x-intercept, so you have one real solution. If you have 0, then you have two imaginary solutions. Okay? If your discriminant is greater than 0, and I would just write it underneath this because the terms the books use isn't necessarily the ones I use. If your discriminant is greater than 0, it's two real. If it's equal to 0, it is one real. And if it is less than 0, then it is two imaginary. Okay? These bottom 2 rows, it talks about the vertex form and the standard form, but it does get a little sign happy in how it explains it. Okay, there's a bunch of less thans, greater thans, equal to, not equal to. Okay, as far as the vertex form is concerned, I think the previous table we filled out, where we put 2x, whatever, that makes more sense. And then just looking at the quick example that I showed you of a factored form that has real solutions versus imaginary, that's a lot easier to read than all that stuff. Okay.